Welcome everyone to Session 2. In today's session, we will learn one of the most important Python libraries for data science and machine learning, pandas. Pandas is a powerful library used to read, organize, clean, transform, and analyze data efficiently. Almost every data science and machine learning project begins with data preprocessing, and pandas provides all the essential tools required for this task. During this session, we will understand what pandas is and why it is widely used, how to install and import the pandas library, the two primary data structures, series and data frame, how to load data from CSV and Excel files, how to inspect, clean, filter, sort, and manipulate datasets, how to handle missing values and duplicate records, how to perform basic statistical analysis, how to prepare data for machine learning models. By the end of this session, you will be able to confidently work with real-world datasets and perform the most common data manipulation tasks required in data science projects. Let's begin our journey with pandas. Hello, everyone. In this session, we'll begin learning one of the most important Python libraries for data science, pandas. The name pandas is derived from the term panel data, which refers to multidimensional, structured data used in statistics and economics. Today, pandas has become the standard library for working with structured data in Python. Pandas provides powerful and easy-to-use data structures that allow us to load, organize, clean, transform, analyze, and visualize data efficiently. Instead of writing complex loops and manual calculations, we can perform many operations with just a few lines of code. One of the biggest strengths of pandas is its ability to handle real-world datasets. These datasets often contain missing values, duplicate records, inconsistent formatting, and other data quality issues. Pandas provides built-in functions to clean and pre-process such data before applying machine learning algorithms. It is widely used in data science, machine learning, business intelligence, finance, healthcare, scientific research, and many other industries where data analysis plays a critical role. Throughout this course, we'll use pandas extensively to read data from CSV and Excel files, filter and sort records, perform statistical analysis, combine multiple datasets, and prepare data for machine learning models.
Before we can analyze data using pandas, we first need to import the data into our Python program. Pandas supports a wide variety of file formats, including CSV, Excel, JSON, SQL databases, and many others. However, in most real-world data science and machine learning projects, the CSV file format is by far the most commonly used. To read a CSV file, pandas provides the pd.readCSV function. We simply provide the path to the file, and pandas loads the contents into a data frame, which we'll study in the next few slides. After loading the data, we can display it using functions such as print or head to verify that it has been imported correctly. You may also encounter tab-separated files, often called TSV files. These files are similar to CSV files, but instead of commas as separator, they use tab characters to separate values. Pandas can read these files by specifying the separator using the sep parameter, for example, sep equals tab. Alternatively, you can open the file in Excel and save it as a CSV file before importing it. The toString method in print converts the entire data frame into one formatted string or text so that all rows and columns are displayed. Although the returned object is a Python string, print displays the contents of the string directly, so quotation marks are not shown. The quotes exist only when defining or representing a string in Python, not when printing it.
In this slide, we'll learn how to tell pandas where our data file to be imported is located. When we import a CSV file using the pd.read.csv function, the most important thing is to provide the correct file path. If the path is incorrect, Python will return a file not found error. There are several ways to specify the location of the file. The first option is to use an absolute path. An absolute path starts from the root of the drive and includes the complete location of the file. Notice that in Python we generally use forward slashes, as on Windows. Alternatively, we can use double backslashes, because a single backslash is treated as an escape character in Python strings. The second option is to use a relative path. A relative path specifies the location of the file relative to the current Jupyter Notebook or Python script. If the CSV file is stored inside the current folder, we can use dot notation. Here, the dot represents the current directory. If the file is located one folder above the current directory, we use two dots, which represent the parent directory. Similarly, if the file is inside another folder, from the current working directory, we can specify that folder name. If you open Google Colab, then on your left side can click the folder icon, and it will take you to the content folder, and it has sample data folder. So you can directly open your file if it's in the content folder, or you mention the folder name, like sample data. One advantage of relative path over absolute path is you don't have to mention the full path, and if anyone opens the file, he will have different absolute path. So it is better to use relative path. If the CSV file is saved in the same folder as the Jupyter Notebook, we only need to provide the file name. This is the approach when working in Jupyter Notebook or Google Colab. Understanding file paths is essential because errors may occur while importing data due to incorrect file paths. You need to use different importing function based on the file type, as there are different functions to import tab file, CSV file, Excel file, or import file from web location, etc.
Hello everyone! In this slide, we'll learn about some of the most useful properties and functions available in a pandas data frame. These functions help us quickly understand the structure, size, and contents of our dataset before performing any analysis. Let's start with the shape property. The shape property returns a tuple containing the number of rows and columns in the data frame. For example, if the output is 169, 5, it means the dataset has 169 rows and 5 columns. Next is the describe function. This function generates summary statistics for numerical columns. It provides information such as the count, mean, standard deviation, minimum value, maximum value, and different percentile values. It is very useful for getting a quick statistical overview of the data. The info function displays general information about the data frame. It shows the number of rows, column names, data types of each column, the number of null values, and the memory used by the data frame. This helps us identify missing values and verify that each column has the correct data type. Next, we have the head and tail functions. The head function displays the first few rows of the data frame, while the tail function displays the last few rows. If we do not specify any number inside these functions, both head and tail return 5 rows by default. df.head returns the first 5 rows, whereas df.head10 returns the first 10 rows. Similarly, df.tail returns the last 5 rows, and df.tail10 returns the last 10 rows. These functions are extremely useful for quickly inspecting the beginning and end of a dataset without displaying the entire data frame. Together, the shape, describe, info, head, and tail functions are among the first commands we typically use after loading a dataset into Pandas. Pandas is one of the most widely used libraries for data analysis, data manipulation, and data cleaning. It provides powerful data structures, such as series and data frames, which make it easy to work with tabular data similar to Excel spreadsheets or database tables. Before using Pandas, it must first be installed on your computer. If it is not already installed, you can install it using the command pip install pandas. This is generally a one-time installation. The command downloads the latest version of Pandas from the Python package index and installs it on your system. Once the installation is complete, we import the library into our Python program using import pandas as pd. Here, pd is a short alias for the pandas library. Although Python allows any alias, pd has become the standard convention used by data scientists and Python developers worldwide. After importing the library, it is good practice to verify that the installation was successful by checking the installed version. We can do this using print pd.version. If a version number is displayed, it confirms that Pandas has been installed correctly and is ready to use. Finally, remember that Python is case-sensitive. The keyword import, the library name pandas, and the alias pd must all be typed exactly as shown. Proper indentation is also important when writing Python programs. You can install and import multiple libraries in one command line rather than writing individual import or install statements, but individual statement is better readable. In this slide, we'll learn how to create a Pandas data frame from a Python dictionary. A dictionary is one of Python's built-in data structures. It stores data in the form of key-value pairs, where each key represents a column name and the corresponding value is a list of data for that column. In this example, we create a dictionary named dict1_cars. It contains 2 keys, cars, and passings. The cars keys stores the names of different car brands, while the passings keys stores the corresponding numerical values. One advantage of dictionaries is that they are flexible. We can easily add new keys, remove existing keys, or modify the values whenever required. However, before performing data analysis with pandas, the data should be converted into a data frame. A data frame organizes the data into rows and columns, making it easier to view, manipulate, filter, sort, and analyze. We perform this conversion using the pd.dataframe function and pass the dictionary as its argument. The resulting data frame is stored in the variable mydf1_cars. Finally, we use the print function to display the data frame. Notice how the dictionary data is automatically arranged into a clean tabular format with row indexes and column names. One important programming practice is to use meaningful variable names. Instead of using names like df1 or data1, use descriptive names such as carsdf, employeedf, or salesdf. Meaningful names make your code easier to read, understand, debug, and maintain, especially when working on large projects or collaborating with other developers.
A pandas series is a one-dimensional labeled array capable of storing data of almost any type, including integers, floating point numbers, strings, Boolean values, and even Python objects. You can think of a series as a single column of data in a spreadsheet or database table. Every value in the series has an associated index, which uniquely identifies its position. In this example, we first create a simple Python list containing the values 2, 7, and 3. We then convert this list into a pandas series using the pd.series function. The resulting series is stored in the variable myvar. When we print the series, notice that pandas automatically assigns index values starting from 0. Therefore, the first value has index 0, the second has index 1, and the third has index 2. Next, we use the type function to determine the type of the object we created. The output confirms that myvar is a pandas series rather than a standard Python list. These index labels are very useful because they allow us to access individual elements quickly. For example, myvar0 returns the first value. By default, pandas generates numeric indexes automatically. Later, we'll learn how to create custom indexes, allowing us to use meaningful labels instead of numbers. Understanding the pandas series is important because it forms the building block of a data frame. Each column in a data frame is essentially a pandas series.
In the first example, we begin with a Python list containing the values 2, 7, and 3. Instead of using the default numeric indexes, we pass an additional parameter called index while creating the series. Here, we specify the labels A, B, and C. As a result, these labels replace the default indexes. Now, the value 2 is associated with label A, the value 7 with label B, and the value 3 with label C. This makes the data much easier to understand because the labels can represent meaningful names instead of simple numbers. We can now access an element using its label, such as myvar of B, instead of using a numeric index. The second example demonstrates another convenient way to create a series, using a Python dictionary. Here, we create a dictionary named calories, containing 3 key value pairs. When we pass this dictionary directly to the pd.series function, pandas automatically uses the dictionary keys as the index labels, and the corresponding values as the series values. Notice that the labels day 1, day 2, and day 3 become the indexes automatically, while the calorie values become the data stored in the series. For example, you are storing stock price of certain stock, let's say Amazon, or can be temperature of a location, let's say New York. Now you can directly see how much of percentage change with respect to previous day or past 30 days.
A pandas series represents a single column of data, whereas a data frame represents an entire table containing multiple rows and columns. You can think of a data frame as an Excel spreadsheet or a SQL database table. In this example, we first create a Python dictionary named data. The dictionary contains 2 keys, calories and duration. Each key represents a column, and the list associated with each key represents the values stored in that column. We then create a data frame by passing this dictionary to the pd.dataframe function. As you can see in the output, pandas creates a table with 2 columns and assigns row indexes starting from 0. Once a data frame is created, there are several useful functions that help us explore the data. Printing the data frame variable, such as myvar, displays the entire table. myvar.info provides information about the data frame, including the number of rows, columns, data types, and memory usage. myvar.describe generates descriptive statistics, such as count, mean, minimum, maximum, and standard deviation for numerical columns. These functions are commonly used as the first step in every data analysis project to understand the dataset before performing cleaning or visualization. One important point to remember is that data frame is case sensitive. The letters D and F of the data frame function must always be capital letters.
In this slide, we'll learn how to retrieve rows from a pandas data frame using the .lock attribute. The .lock attribute is one of the most commonly used indexing methods in pandas. It allows us to select one or more rows based on their row labels or indexes. In case of df.lock0, the pandas returns the first row of the data frame. Notice that the output is returned as a pandas series because we are selecting only one row. Next, if we want to retrieve multiple rows, we can pass a list of indexes. For df.lock01, here pandas returns both the first and second rows. Since multiple rows are selected, the output is returned as another data frame instead of a series. One of the biggest advantages of .lock is that it also works with custom row labels. In the example shown on the right, the data frame uses labels such as day 1, day 2, and day 3 instead of numeric indexes. df.lock day 2 retrieves the row whose label is day 2. This makes the code much more readable because we can use meaningful labels instead of remembering row numbers. Remember this important point. Selecting a single row returns a series. Selecting multiple rows returns a data frame. Throughout data analysis, .lock is frequently used to filter records, retrieve specific observations, and work with labeled datasets.
We will learn how to read JSON, JavaScript Object Notation, files using the pandas library. JSON is one of the most widely used formats for storing and exchanging data between applications and web services. Many REST APIs and web applications return their data in JSON format because it is lightweight, human-readable, and easy for machines to parse. A JSON object is very similar to a Python dictionary, where data is stored as key-value pairs. This similarity makes it very convenient to work with JSON data in Python. To load a JSON file into a pandas data frame, we use the pd.readJSON function. The data is automatically converted into a data frame. Once the data is loaded, we can perform all the standard pandas operations, such as filtering, sorting, grouping, cleaning, and statistical analysis. JSON files are commonly used when working with web APIs, cloud services, configuration files, and NoSQL databases, such as MongoDB.
In this section, we will discuss null values, also known as missing values, or NA, not available values, in a dataset. Missing values occur when information is unavailable for one or more records. These values can affect data analysis and reduce the performance of machine learning models if they are not handled properly. To identify missing values, we can use the df.info method. This method provides useful information about the data frame, including the total number of rows and columns, the data type of each column, the number of non-null values in every column, the memory usage of the data frame. In the example shown on this slide, the dataset contains 169 rows. Most columns have 169 non-null values, but the calories column has only 164 non-null values. This indicates that 5 values are missing in that column. Before training a machine learning model or performing statistical analysis, we should always inspect the dataset for missing values. Depending on the situation, we can remove rows containing missing values, fill missing values with the mean, median, or mode, use forward fill or backward fill techniques, replace missing values with a suitable constant or prediction. Handling missing values correctly improves data quality and leads to more accurate and reliable machine learning models. In the previous slide, we learned how to identify missing values in a dataset. In this section, we will discuss different techniques for handling those missing values. Missing values are common in real-world datasets and should always be handled before performing data analysis or training machine learning models. If left untreated, they can lead to inaccurate results or even cause algorithms to fail. One of the simplest approaches is to remove rows containing missing values using the drop_NA function. The drop_NA function removes all rows that contain one or more missing values. Another approach is to replace missing values using the fill_na function instead of deleting valuable data. This replaces every missing value in the calories column with the average value of that column. Depending on the dataset, we can also replace missing values using the mean for numerical data, the median when there are outliers, the mode for categorical data, forward fill, which copies the previous valid value, backward fill, which copies the next valid value. Notice the in_place equals true parameter used in drop_na. When in_place equals true is specified, the original data frame is modified directly, and there is no need to assign the result back to the data frame. If in_place equals false, the default, a new data frame is returned, so we must save it. Before we perform data analysis or build a machine learning model, we must ensure that our data is clean and reliable. This process is known as data cleaning. Data cleaning is the process of identifying and correcting errors, inconsistencies, and missing information in a dataset. High-quality data leads to more accurate analysis and better performing machine learning models. Some common data quality issues include missing or empty values, where some information is unavailable, incorrect data, such as impossible or unrealistic values, wrong data formats, for example, storing dates as text instead of date objects, duplicate records, where the same observation appears multiple times, outliers, which are unusual values that may result from data entry errors or measurement issues. In the example shown on this slide, we can observe that rows 17 and 27 have missing values in the calories column. Row 69 contains an incorrect value in the duration column. A duration of 300 minutes appears unrealistic compared to the other workout durations in the dataset. Before proceeding with analysis, we need to investigate such issues and decide whether to remove, replace, or correct these values. Data cleaning is often the most time-consuming part of a data science project, but it is also one of the most important because the quality of the output depends on the quality of the input data. Imagine a hospital is collecting patient data. One patient's age is missing. Another patient's age is entered as 250 years. A patient record appears twice in the database. A date is entered as 31/02/2025, which is an invalid date. If this data is used without cleaning, the analysis could produce misleading results and affect important decisions. By cleaning the data first, we ensure that the analysis is based on accurate and consistent information. In our example of row 69, if you see a workout duration of 300 minutes, while most workouts last between 30 and 90 minutes, would you trust that value? What could have caused it? Probably it is a data entry mistake, perhaps 30 was entered as 300, or incorrect unit of measurement. In this section, we will learn how to identify two common data quality issues: duplicate records and incorrect data formats. Duplicate records occur when the same information appears more than once in a dataset. These duplicates can distort statistical analyses, bias machine learning models, and lead to inaccurate conclusions. In the example shown on this slide, notice that rows 11 and 12 contain exactly the same values. This is a duplicate record and should be identified before further analyses. Another common issue is inconsistent data formats. In this dataset, the date column contains dates in different formats. Some dates are stored as strings enclosed in quotes, while others may be stored as actual date values. Although these values may look similar, pandas may interpret them differently. This can create problems when sorting data, filtering by date, or performing time series analysis. To solve this problem, we convert the entire column into a consistent date-time format using pandas. After identifying duplicates and correcting date formats, the dataset becomes more reliable and ready for analysis or machine learning. Duplicate rows can lead to incorrect analysis. Use duplicated to identify duplicate records. Use drop duplicated to remove duplicate rows. Date columns should have a consistent format. Convert date strings into date-time objects using pandas.toDateTime. Clean and consistent data improves analysis and machine learning performance. Remember that data cleaning is not only about removing missing values, it also involves ensuring that every record is unique and every column follows the correct data type and format. We know how to remove rows that contain missing or empty values using the drop_na function in pandas. When working with real-world datasets, it is common to encounter rows with one or more missing values. If only a small percentage of the data is missing, one simple solution is to remove those rows entirely. Here, the drop_NA function removes all rows that contain at least one missing value. The parameter in_place equals true means that the original data frame is updated directly. If we do not use in_place equals true, the function returns a new data frame. Removing missing values is often a good choice when the dataset is very large. Only a few rows contain missing values. Removing those rows does not significantly affect the analysis. However, we should not always delete missing values. For example, consider a stock market dataset where the stock price for a particular day is missing. If we remove that row, we may lose important time series information. Similarly, in weather data, if the temperature value is missing, replacing it with 0 degrees Celsius may not be correct, because 0 may represent an actual temperature rather than a missing value. Therefore, before removing missing values, we should understand the data and decide whether deleting or filling the missing values is the better approach. We learned how to remove rows containing missing values using drop_NA. However, deleting rows is not always the best option because it may result in the loss of valuable information. Another common approach is to replace missing values using the fill_NA method. For example, if we want to replace all missing values with a fixed value, here, every missing value in the data frame is replaced with 130. In practice, replacing every missing value with the same constant is not usually recommended. A better approach is to calculate a representative value from the data. In this example, we first calculate the average, mean, of the calories column. Then we replace every missing value in that column with the calculated mean. Similarly, we can replace missing values using mean, suitable for normally distributed numerical data; median, preferred when the data contains outliers; mode, commonly used for categorical data. After replacing the missing values, we should always verify that no null values remain. df.isNAA.sum. If every column shows 0, it means all missing values have been handled successfully. We will learn why converting data into the correct format is an important step in data cleaning. When we import data from a CSV or Excel file, Pandas automatically assigns a data type to each column. However, the assigned data type may not always be correct. For example, a date column is often imported as an object, which means it is treated as plain text rather than as a date. If we check the data frame using df.info, we can see that the date column has the data type object. When a date is stored as text, we cannot easily perform date-related operations such as sorting records by date, filtering data by month or year, calculating the difference between two dates, creating time series visualizations. To solve this problem, Pandas provides the pd.toDateTime function. We can convert the date column into a proper datetime format using this function. After conversion, if we execute df.info again, we will notice that the data type changes from object to datetime64nfs. This tells us that Pandas now recognizes the column as a true date field. Converting columns to their appropriate data types is an essential data cleaning step because it improves both performance and accuracy when analyzing data. Imagine an e-commerce company wants to answer questions like, how many orders were placed in January 2025? What were the total sales in December? Which month had the highest revenue? If the order date column is stored as text, these tasks become difficult or unreliable. By converting the column to the datetime type, we can easily perform operations such as in the slide. So why do you think a computer should store dates as a datetime object instead of simple text? You know now? If the date column has a null value, we can remove it with a drop_NA function. Either we can assign the result of drop_NA to a new data frame variable, or use in_place equals true instead, and it will update the existing data frame df. Below is the result after the drop_NA operation has been performed on data frame df. We will learn how to identify and correct incorrect or unrealistic values in a dataset. During data collection, errors can occur because of manual data entry mistakes, faulty sensors, or system issues. These incorrect values are known as wrong data. In this example, we are working with a workout dataset. Most exercise durations are between 30 and 100 minutes, but a few records show durations of 210, 270, and 300 minutes. These values are unusual and should be investigated before analysis. First, we identify these records using a condition. This displays all rows where the duration is greater than 200 minutes. Suppose we verify that the value in row 69 is a typing mistake and should actually be 45 minutes instead of 300 minutes. We can correct it using lock attribute and specifying the index and column name. After updating the value, we can run the same query again to verify that row 69 no longer appears in the list of incorrect values. Sometimes, if the correct value is unknown, we may remove the row, replace it with the mean or median, investigate the original data source before making changes. The goal of data cleaning is not only to remove errors, but also to ensure that the dataset accurately represents real-world conditions. In the previous slide, we corrected a single incorrect value manually using the lock function. While this approach works for 1 or 2 records, it becomes inefficient when a dataset contains many incorrect values. In this slide, we learn how to automate the correction process using a for loop. Suppose we know that any workout duration greater than 250 minutes is incorrect. Instead of correcting each row individually, we can loop through every row in the data frame and check whether the duration value exceeds 250. If the condition is true, we update the value automatically. In this code, df.indexed iterates through all row indices. df.lockXDuration accesses the duration value of each row. If the duration is greater than 250, it is replaced with 75. Notice that row 79, which previously had a duration of 270, no longer appears because it has been corrected. Now only the remaining rows with values greater than 200 are displayed. This confirms that our automated correction worked successfully. Using loops is especially useful when cleaning large datasets containing thousands or even millions of records. A bank might correct negative account balances caused by system errors. An online shopping platform could detect unrealistic product prices, such as 500,000 rupees instead of 5,000 rupees. A hospital database might identify impossible patient ages, such as 300 years. In this section, we will learn one of the most commonly used techniques in pandas, Boolean indexing. Boolean indexing allows us to filter data based on one or more conditions without modifying the original data frame. The first step is to create a Boolean series. This statement does not return the actual rows. Instead, it creates a Boolean series containing true and false values. True indicates that the condition is satisfied. False indicates that the condition is not satisfied. Next, we use this Boolean series to create a new data frame. Now, df1 contains only the rows where the duration is greater than 250. Notice that the original data frame df is not modified. This is an important advantage because we can preserve the original dataset as a backup while performing different analyses on separate filtered data frames. So we discussed many methods to correct wrong data. Remove null rows, correct row values using Boolean indexes, or for loop based on some condition. Replace null values using mean, median, mode for numerical data. The duplicated method returns a Boolean series. True indicates that the row is a duplicate. False indicates that the row is unique. By using Boolean indexing, we create a new data frame called duplicates that contains only the duplicate rows. This approach has several advantages. We can inspect duplicate records before deleting them. The original data frame remains unchanged. We can export duplicate records for auditing or reporting. We can decide whether to remove or retain duplicates based on business requirements. Once we confirm that the duplicate records are unnecessary, we can remove them. This two-step process, identify first, then remove, is considered a safer and more professional data cleaning practice. If you find duplicate records in a banking transaction dataset, would you delete them immediately or inspect them first? Some duplicate records may represent legitimate repeated transactions. Others may be caused by data entry or synchronization errors. For example, you want some customer master dataset to represent unique keys only or as primary keys, so you need to delete duplicate records with same ID, name, description, address, etc. Reviewing duplicates before deletion reduces the risk of removing valid information. Question 1. Suppose we have a data frame containing a column named first name, and we want to change the value of the first row to John. How can we do that? Here, 0 represents the row index, first name specifies the column, John is the new value that replaces the existing value. The lock method is commonly used to access or modify specific rows and columns based on their labels. Question 2. Suppose we want to create a new data frame that contains only the pulse and max pulse columns. Notice that we use double square brackets because we are selecting multiple columns. If we use only one pair of brackets, Pandas assumes we are selecting a single column. Question 3. Suppose we want to rename the selected columns. For example, pulse to pulse 2, max pulse to max pulse 3. Now the data frame still contains the same data, but the column names have changed. We have also learned that iloc can be used for integer-based indexing. Unlike loc, which works with row and column labels, iloc selects data using row and column positions. Understanding both loc and iloc is essential because they are among the most frequently used indexing techniques in Pandas. For example, if you want to update the database table with your data file, then we have to take care about the field names because it is very particular about field names to be exact. We will learn about correlation, which measures the relationship between two variables. Correlation tells us whether two variables move together and how strongly they are related. For example, in a fitness dataset, we may want to know, does exercise duration increase the number of calories burned? Does heart rate increase with exercise intensity? Is there a relationship between age and blood pressure? Correlation helps us answer these types of questions. The correlation coefficient always lies between -1 and +1. Let's understand what these values mean. Perfect positive correlation, +1. A correlation value of +1 means the two variables move together perfectly. If one variable increases, the other also increases in exactly the same proportion. For example, hours studied and marks obtained, in an ideal case. Distance traveled and fuel consumed. No correlation, 0. A correlation value of 0 means there is no meaningful relationship between the variables. Knowing the value of one variable does not help us predict the other. For example, shoe size and exam marks, employee ID and salary. Strong negative correlation, -0.8 or -0.9. A value close to -1 indicates a strong negative relationship. When one variable increases, the other tends to decrease. For example, vehicle speed and travel time, price of a product and customer demand. Why is correlation important in machine learning? Correlation is useful for feature selection. Suppose two features have a correlation greater than 0.75 or 0.80. For example, height in inches, height in centimeters. These two features contain almost identical information. Keeping both columns may introduce redundancy and can make some machine learning models less efficient. In such cases, we often remove one of the highly correlated features and keep the other. This reduces redundancy, speeds up training, and can improve model interpretability. However, remember that high correlation does not always mean one variable causes the other. Correlation only measures association, not causation. In this slide, we will learn how to interpret a correlation matrix generated using Pandas. A correlation matrix displays the correlation coefficient between every pair of numerical variables in the dataset. For example, in this workout dataset, we are analyzing 4 variables: duration, pulse, max pulse, calories. Each value in the matrix tells us the strength and direction of the relationship between two variables. Relationship between duration and calories. Notice that duration and calories have a strong positive correlation. This tells us that, in general, people who exercise for a longer duration tend to burn more calories. However, it is important to understand that correlation does not prove causation. For example, someone exercising for a longer time at a very slow pace may burn fewer calories than someone exercising intensely for a shorter period. Correlation simply tells us that the two variables tend to move together. Relationship between pulse and max pulse. We can also see that pulse and max pulse have a strong positive correlation. This makes sense because both measure heart activity during exercise. As the average pulse increases, the maximum pulse usually increases as well. Weak relationship. Some pairs of variables have weak correlations. For example, if the correlation between two variables is close to 0, knowing one variable tells us very little about the other. Using correlation for feature selection. One important application of correlation is feature selection. If two input features are extremely highly correlated, for example 0.95 or above, they provide nearly the same information. Keeping both features may not improve the model and may introduce redundancy. In such cases, we often remove one of the correlated features. This simplifies the model and reduces computational cost. Correlation does not mean causation. Just because two variables move together does not mean one variable causes the other.
There may be other hidden factors affecting both variables.
Question: what is the correct syntax to create a pandas series from a Python list? Suppose we have a Python list. The series function converts a Python list into a one-dimensional pandas object called a series. A pandas series contains the actual data values, an index associated with each value. Notice that pandas automatically creates index values starting from 0. If we want custom index labels, we can specify them using the index parameter.
In this slide, we will look at some commonly used pandas data frame methods that begin with the letter A. These methods help us perform mathematical operations, modify column labels, and analyze the values stored in a data frame. Let's briefly understand each method. abs.dot returns the absolute positive value of every numeric element in the data frame. It converts all negative values into positive values. add.dot adds a specified value or another data frame or series to the existing data frame elements. add_prefix.dot adds a specified prefix to the beginning of every column name, useful when combining multiple datasets. add_suffix.dot adds a specified suffix to the end of every column name. This helps distinguish similar columns after merging data. all.dot checks whether all values in a row or column satisfy a condition, returns true only if every value meets the condition. aggregate.dot ag.dot applies one or more summary functions such as sum, mean, minimum, or maximum to rows or columns. any.dot checks whether at least one value in a row or column satisfy a condition, returns true if any value meets the condition.
In this slide, we continue learning about commonly used pandas data frame methods. These methods help us manipulate data, apply functions, change data types, access specific values, and handle missing data. Let's briefly understand each method. Append appends or combines data by adding rows from another data frame or series. Note, in recent pandas versions, this method has been deprecated in favor of concat. ApplyMap applies a specified function to every individual element in the data frame. Apply applies a function to an entire row or column of the data frame. Assign creates one or more new columns or updates existing columns without modifying the original data frame unless reassigned. AsType converts the data type of a column or data frame, such as converting integers to floats or strings to dates. Accesses or updates the value of a single cell using its row and column labels. It is optimized for fast access to one value. Axes returns the labels of the data frame axes, including the row index and column names. bfill, backward fill, replaces missing, null, or nan values using the next valid value in the column or row. In this slide, we continue exploring useful pandas data frame methods that begin with the letter C. These methods are commonly used for comparing data frames, converting data types, and analyzing relationships between columns. Let's briefly understand each method. .bool returns the Boolean value, true or false, of a data frame or series when it contains a single Boolean element. Columns returns the names or labels of all the columns in the data frame. It is useful for viewing or modifying column names. Combine combines two data frames by applying a specified function to corresponding elements, allowing you to define how values should be merged. Combine first combines two data frames by filling missing values in the first data frame with corresponding values from the second data frame. Compare compares two data frames and displays only the cells where the values are different. It is useful for identifying changes between datasets. Convert data types automatically converts columns to the most appropriate and efficient data types, improving consistency and memory usage. Core calculates the correlation between numerical columns in a data frame. It helps identify whether variables have a positive, negative, or no relationship. These methods are especially useful when working with multiple datasets, handling missing values, optimizing data types, and performing exploratory data analysis, EDA. They help make data comparison, cleaning, and analysis more efficient. In this slide, we continue learning about additional data frame methods that begin with the letter C. These methods help us count values, calculate statistical measures, create copies of data, and perform cumulative operations. Let's briefly understand each method. Count function
returns the number of non-empty, non-null values in each row or column. It is commonly used to check how much valid data is available. Cov function calculates the covariance between numerical columns. Covariance indicates whether two variables tend to increase or decrease together. Copy function creates a separate copy of a data frame. Changes made to the copied data frame do not affect the original data frame. Cum max function calculates the cumulative maximum value. At each step, it keeps track of the largest value encountered so far. Cum min function calculates the cumulative minimum value. It keeps track of the smallest value seen up to each row. Cum prod function calculates the cumulative product of values. Each value is multiplied by all the previous values in sequence. Cum sum function calculates the cumulative sum of values. Each value represents the total of all previous values plus the current value. These methods are widely used in data analysis, statistics, financial analysis, and time series data.
In this slide, we will explore commonly used pandas data frame methods that begin with the letter D. These methods are useful for summarizing data, performing mathematical operations, and removing unwanted rows or columns. Let's briefly understand each method. Describe dot generates a statistical summary of the data frame, including measures such as count, mean, standard deviation, minimum, maximum, and quartiles for numerical columns. Diff dot calculates the difference between the current value and the previous value in a row or column. It is commonly used to analyze changes over time. Diff dot performs element-wise division of data frame values by a specified value, series, or another data frame. Dot dot calculates the dot matrix product between a data frame and another data frame, series, or array. It is commonly used in linear algebra and machine learning calculations. Drop dot removes specified rows or columns from a data frame. It is useful for deleting unnecessary or unwanted data. Drop duplicates dot removes duplicate rows from a data frame, ensuring that only unique records remain. Drop level dot removes one or more levels from a hierarchical, multi-index, row, or column index, simplifying the data frame structure.
We have now reached the end of our pandas session. Thank you all for your participation and attention throughout today's session. I hope you enjoyed the session as much as I did. Today, we covered the fundamentals of pandas, one of the most important Python libraries used in data science and machine learning. During this session, we learned how to install and import the pandas library, create and work with series and data frames, read data from CSV, Excel, and JSON files, explore datasets using functions such as head.tail, info.tail, and describe.tail, handle missing values using drop.na and fill.na, clean datasets by correcting wrong values and converting data into the appropriate format, detect and remove duplicate records, filter data using Boolean indexing, select rows and columns using lock.square bracket and ilock.square bracket, rename columns and update individual values. These are the core data pre-processing skills that every data scientist and machine learning engineer uses before building predictive models. Remember this important principle. The quality of a machine learning model depends on the quality of the data. Spending time cleaning and understanding your data often has a greater impact on model performance than simply trying advanced algorithms. For your practice, I encourage you to download a real-world dataset from Kaggle or the UCI Machine Learning Repository. Perform data cleaning using the techniques learned today. Explore the dataset by creating summaries and visualization charts and answering simple business questions. Thank you again for attending. I hope this session has given you a solid foundation in working with data using pandas.